Carbon fiber is really one of the fundamentals really to make a car strong, very light, safe and have fantastic performance. It creates massive rigidity but does not add weight, which is crucial if you want to make a really efficient, fast and fun sports car to drive. As far as we're aware, our cars are the most carbon fiber intense cars in production right now, as we have over 400 different carbon fiber pieces. This here is an intake for the engine, intake plenum. We have some pressurized turbo pipes, valve cover, and even parts like the engine, as we can see here, are made of carbon fiber, especially the parts up top on the engine to get the center of gravity low. So what we're seeing here is something as very simple as a tube. It's a turbo piping, and what I have in front of me here is a machined mold from aluminium. Even a simple detail like a tube needs a lot of thought to make it perfect. The CAD model is flow to check that the flow is perfect, that it has enough volume to pass enough air to the engine at top power levels and top RPM levels. It also has to have a shape which is strong enough and a calculated thickness of the carbon fiber so that it can take the boost pressure. You can see here that it's kind of a funky shape to it, that it's flow optimized for this curve. We have an integrated mount here for a pressure and temperature sensor. Actually, when we manufacture a carbon fiber part from this tool, the first thing we do is to put a release agent here, because in the carbon fiber prepreg, which I have here, which is actually the material the part is made out of, it's pre-impregnated with the two-component epoxy. So if this would be put down here without release agent, it would actually stick to the tool. And then this material, the carbon fiber, is cut to suit the tool part. This is not optimized for this now. I just took a small piece, but it's applied like this, layer by layer, different amount of layers depending on the need. So that's actually what's going to become the part. Then we need to pressurize. We need heat and pressure to consolidate this, to get it to have the right strength and the right properties. So in order for the rest of the process not to get the processing material not to get stuck into the carbon fiber and the epoxy, we put this kind of release film here, which is easy to tear off of the part when it's done, and it also makes sure that this breathing fabric, as it's called a breather, doesn't stick to the carbon fiber piece. And what this does, it makes sure that the pressure that this is subjected to, or the vacuum that we also suck out, that it gets spread out and that we don't get pockets of air. It's making sure the atmosphere difference is controlled over the surface. So at the end we put this bagging material over the whole part, and then we seal it off with kind of a goo that is similar to black chewing gum, I would say. So basically these are the elements included in the production of the part. And it's quite intricate, especially with a tube like this that has to then, you put carbon fiber here, we put carbon fiber here, and then these, I'll take this out right now, then they have to match together. And we need this bagging material to come into the tube to pressurize the tube from the inside and then to seal off the tool from the outside. Of course, the thinner, the lighter, but also less strong part. So if it's a safety critical part, or like this, a pressurized part, it really needs to be calculated well to have the right amount of carbon fiber. You never want to put more carbon fiber than you need into a part, because first of all, carbon fiber is expensive, so the part becomes unnecessarily expensive. It takes more time to apply the carbon fiber than is actually needed. And in the end also the part becomes heavier, which is maybe the worst part in a super light sports car. The end result is this tube. So in the end it's a quite simple looking part, but there's a lot of thought that has gone into what it becomes in the end. Already of course from shaping the part, but also when it comes to laying it up and getting the right consolidation. You can see straight from the tool you get a quite nice even surface that doesn't require a lot of hand fettling afterwards. As it is a very complex technology, there are many types of weaves, many types of carbon fiber strands and different philosophies how to apply them. It's a little bit of a black art really, and really lessons learned and what kind of philosophies you're working towards. But we have been developing carbon fiber parts since 1994, so I would say we have a quite good experience and can create extreme lightweight and strong parts based on the knowledge we have and the analysis tools we have. So it's really a labor-intensive process, and the persons involved in the manufacturing really needs to know what they're doing to get the desired result. Of course, here we have a much more complex part, so you can imagine what has to go into this compared to a simple tube. And what's nice about carbon fiber is you can vary the strength and thicknesses in different areas with no limit. It's just how much thought you want to put into it and how much labor you want to put into it. But it can be so optimized, like this corner can have a little bit extra carbon, it can be thinner here, we can have a different direction. Not many other materials gives that kind of freedom. At the same time, not many other materials can soak up so much time in the production process. But that's what makes the car extreme and what it is in the end. Koenigsegg and carbon fiber are very closely integrated, and it has to be that way in this very competitive market we're in.